Dear friends, welcome back to DATS Data Analytics Talks. This session is a continuation of our Azure Data Engineer Learning Series. Please check out this playlist for a better understanding of the concept that we have already covered in this series. So, one of the topics that we have covered in this series was modern data warehouse. So, in that session, I have explained how a modern data warehouse is constituted. What are the major components in a modern data warehouse? So we have seen the data sources like structured data, unstructured data, and the ingest and preparation stage where we use Azure Data Factory and Azure Databricks. And we have the model and serve stage where you have the Azure Synapse Analytics, and we have Databricks for training the model and implementing machine learning modules. And finally, we have the data visualization layer using Power BI. So I also explained how data is being stored and managed using data lake, Gen 1, Gen 2 storage, and so on. So today's session, I am going to focus on Databricks. I will introduce some of the basics of Databricks in this session. Databricks has a major role to play in ingest and preparation, especially the data preparation and data massaging and data transformation. And it also plays a big role in model machine learning, where we are training the model. So let's look into the basics of Databricks today. And I will also have another session where I would like to take you to the Databricks platform and show you what is possible with the platform. So here is a little bit of history about the Lakehouse. Now we have heard about data warehouse and we have seen what is data lake. So what is Lakehouse? Here we can see that the data warehouses emerged in 1980s as a solution for organizing structured business data in enterprises. Mostly you have heard about EDW, Enterprise Data Warehouses, which was built using SQL or Oracle. And the data being stored in those enterprise systems were structured, the structured business data. But by 2010, the organization began accumulating a significant amount of unstructured data to support more varied use cases such as AI, artificial intelligence. So that is where data lake came in. To address these, data lake were introduced as an open, scalable system for any type of data. That's where we see data lake. The data lake, we have the raw data, filtered data, and business level aggregates. And it manages structured data, unstructured data, and even semi-structured data, whatever format we can put in data lake. By 2015, it became common for most organizations to operate both the data warehouse and data lakes. So there is a coexistence of data warehouse and data lakes. This dual platform approach, however, presented significant challenges in governance, security, reliability, and management. So there should be a system which can manage everything, right? So that is where we could see that Databricks has pioneered the concept of Lakehouse to combine and unify the best of both worlds, the data lake as well as data warehouse world. So the Lakehouses store and govern all your data in open formats. That's very important to understand. It store open format and natively support workloads ranging from BI to AI. So it is supporting business intelligence as well as artificial intelligence. So Lakehouses offered a unified system to query all data sources in an organization together and govern all workloads that uses data like BI, AI, and so on. So if you look at this visual, you can see that Databricks Lakehouse platform, it supports data engineering, BI and SQL analytics, real-time data applications, then data science and machine learning, and there is a data management governance layer. And it is storing the data in open format where open data lake, and it stores structured data, semi-structured data, unstructured data, and even streaming data. And most importantly, it is supported by the major cloud providers like AWS, Microsoft Azure, and Google Cloud, Oracle Cloud, and so on. So, despite the progress, all current platforms in the market still face several major challenges. So, what are those challenges? Technical skill barriers, See, querying data requires specialized skill in SQL, Python, or BI, creating a steep learning curve. When you are storing multiple types of data, querying them is a bit difficult. And there's a steep learning process to master that enough required technical skills. Then there is problem with the data accuracy and creation. So data accuracy and creation means what? In large organization, finding the right and accurate data is a challenge, requiring extensive curation and planning. Then there is management complexity. What is management complexity? So the data platforms can skyrocket in cost and experience poor performance. So if not managed by highly technical personnel, you cannot get expected return on that. Then we have problem with governance and privacy. The governance requirements across the world are rapidly evolving, and with the advent of AI, concerns around lineage, security, and privacy are amplified. So that is a major problem that is being faced in the market. Finally, the emerging AI application. What is that emerging application challenge? So in order to enable generative AI applications that answer domain-specific requests, organizations have to develop and tune LLMs in platforms that are separate from their data and connect to them to their data through manual engineering. That's a big challenge many data platforms are facing today. So the Databricks has emerged as a data intelligence platform which leverages the governance and security of the major cloud platforms like Microsoft Azure, Oracle Cloud, and Google Cloud, and so on. Going to some of the feature of Databricks, you can see that Databricks is a data intelligence platform. It allows your entire organization to use data and AI. It is a unified governance and unified data. And supports business intelligence, data warehousing, AI and data science, ETL and real-time analytics, and overall orchestration. And is again built on Open Data Lake. And it is an intelligent platform because it combines generative AI with the unification benefits of a Lakehouse to power a data intelligence engine that understands the unique semantics of your data. And again, it is simple. The natural language substantially simplifies the user experience on Databricks. The data intelligence engine understands your organization's language, so search and discovery of new data is easy. And finally, it is private. The data and AI applications require strong governance and security, especially with the advent of generative AI. And Databricks provide an end-to-end MLOps and AI development solution that is built upon our unified approach to governance and security. The Databricks Intelligence Platform enables your data and AI workloads where you can do data sharing, data engineering, data governance, data warehousing, artificial intelligence, data science, real-time streaming, and marketplace. So it's quite interesting technology. So we should all master it, right? So we will hear what Databricks wants to tell you about its features.
Databricks was founded in 2013 by the original creators of Apache Spark, Delta Lake, and MLflow. As the world's first and only Lakehouse platform in the cloud, Databricks combines the best of data warehouses and data lakes to offer an open and unified platform for data and AI. Databricks is the inventor and pioneer of the data lakehouse architecture, coining the term in the research paper, Lakehouse, a new generation of open platforms that unify data warehousing and advanced analytics, co-authored by the Databricks founders, UC Berkeley and Stanford University in 2021. The Lakehouse paradigm is designed as the ideal data and AI platform for all data types that is open with a single security and governance model. Not only is it designed to manage all data types, but it is cloud agnostic, so data can be governed wherever it is stored. Because its purpose is to support all major data and AI workloads, teams can easily collaborate and access all the data they need to keep innovating and improving. All of these architectural features are realized on the Databricks Lakehouse platform, including the reliability and performance of Delta Lake as the data lake foundation, a fine-grained governance for data and AI with Unity Catalog, and support for persona-based use cases for all data team members. The Databricks Lakehouse platform architecture also provides instant and serverless compute, where Databricks provides and manages the compute layer on behalf of the customer. Combining the best elements of data warehouses, such as reliability, governance, and performance, with the openness and flexibility and machine learning support of data lakes, the Databricks Lakehouse platform is a single platform that unifies data warehousing and AI use cases. This unified approach eliminates the challenges caused by previous data environments, such as data silos, complicated structures, and fractured governance and security structures. To reiterate the benefits of the Data Lakehouse platform, first, it is simple by providing a unified platform and eliminating the complexity and expense that stands in the way of achieving the full potential of data analytics and AI initiatives. It is open, with a foundation on Delta Lake for reliability and performance, while avoiding proprietary systems, thus making it easy to share data unrestricted. It allows you to build the ecosystem you need with open-source projects and the vast network of Databricks partners. And it is multi-cloud, allowing you to work on the cloud platform currently in use with a consistent management, security, and governance experience. The Databricks Lakehouse platform supports the workloads for data teams, including data warehousing, data engineering, data streaming, and data science and machine learning. And speaking of partners, the Databricks Lakehouse platform provides the flexibility to use your existing infrastructure, share your data, and build a modern data stack with unrestricted access to open-source data projects and the broad Databricks partner network, including but not limited to those shown here.
Of course, in the next session, we will have a demo. I will run you through Databricks platform and show you what is possible with the Databricks. And we will also try to implement a sample ETL process end-to-end using Databricks in the future sessions. Look out for the next video. So if you like this video, don't forget to like, share, and subscribe, and share your feedback as comments. Thank you.